All right, we're back. It is COMP123 in the summer 2016 semester, and it's week 5, part 4 of our broadcast. We just finished doing a class diagram, talking about that. We're not going to talk about that too much more anymore, although I will be using the class diagram for some examples as we go forward, because it makes sense, just to visualize stuff. Okay, let's take a look at some of the stuff we've talked about before. So we're into inheritance and stuff. One of the things we want to talk about is using the object class. Remember, the object class is the superclass for all classes. So if I make up my own class, person class, by default, I'm inheriting the object superclass, right? And the object superclass comes with several methods, right? Several methods. These are the methods that it comes with: equals, get hash code, get type, and toString, right? So let's talk about toString. That's the easiest one. toString returns a string that represents the object. Well, what would it be if I did like person.toString? How would I represent the object in my as a string? What does it do? What is the person object as a string? Let's check that out. Because person is actually a type of object, then I should be able to say person.toString. No problem, right? Let's complete this this stuff up here. I got teacher and I got student. I got an error here. I can't run my code unless I fix this. Let's get rid of, for now, this is just for examples. I want to get rid of, I want to delete my code for international student and domestic student for now, just to simplify. And my teacher, I want to fix him up, because it'll give me an error, right? So I'm going to double click here. There we go. I'm going to double click on my teacher and fix him or her. And one thing I need is, it has an employee number. I need an employee number. I'm going to type it by hand, because you can do both. In this example, I can say private, right, string, which is the type of employee number, underscore employee number, right? So I've got that now. And then this one obviously would be a string as well, which is my property. And my getter is going to return this dot underscore employee number, right? And the same thing goes with my setter. This dot underscore employee number is equal to value, right? The value that I'm assigning to it. In my teach, I have a teach method. I don't have a constructor yet, but I need one. That's why I'm getting this error. In my teach method, I'm going to say something like, in quotations, just like the same thing as we did before, is teaching. Whatever the name of the person is teaching, right, which is this dot name. Because this dot name exists in my person class, I can use it, right? Cool, right? And what I want to do is create a constructor. And remember, I can do it visually. So we'll go back to here. There's my teacher. Right-click, add a constructor. And then my constructor, which is called teacher, right? If I double-click on my teacher constructor, it goes right there to my teacher, right? I know that I need to take two things. Right, I need the name of the teacher, the age of the teacher, because that's part of the person class, right? I also need the employee number of the teacher, right? So I'll say, so age and name. So int age. I don't know if I did age first and then name. How did I do it? Let me go back and check my person class, right? So if I go to my person class, double click, I can see that my person takes age and then name. So that's what I need to take, the same way. Same signature for my teacher. So age, and then name, and string, name. And I also need to I also have to have a string that represents his employee number, potentially, right? So employee, how about that, Tom? Employee number. Right? Now, when I do that, I also want to send age and name to the base superclass. I'm going to initialize those with age and name, and that'll take away my error, right? Because my only constructor that I have in the person class, the reason why I'm getting that error, is a constructor that takes two parameters. I don't have the empty constructor. I haven't defined it in my person class, therefore it doesn't exist here, right? If I don't define it, once I define a constructor in my class, my default constructor is gone. It's overwritten, right? Unless I define it specifically. I don't need this. What I need to say is this dot underscore, or sorry, this dot employee number is equal to employee number. That's what I get to do there, because it's taking the local employee number that's being passed into the constructor and assigning it to my property. All right, so pretty much I finished my student and my teacher, right? Let's get rid of this, and let's get rid of this. Here's my person diagram. I'm missing one thing here, right, in my person diagram. I'm missing my program. Here's my program, right? This is my driver class. Just drag that in. Right, well, in my driver class, I can see that I have a main method. I want to double click on the main method to take me there. Here it is, I'm in the main method now, right? In the main method, right, what I want to do is I want to make a student, right? And I want to go student.toString. So how do I do that? So I say student name, so student is the actual class. And let's say we'll call it a student name as Tom or Tommy, right? Like we did last time, is equal to a new student. A student takes three values: age, so let's say 20 years old, my name, right, which is Tommy. This is the way we structure this time, and my student number, which is like 1, 2, 3, 4, 5, 6, and with maybe some kind of value in the beginning, like A. Right? So that we can tell that it's an alphanumeric, kind of string value, right? All right, so we get a new student, and now what I want to do is I want to say something like this. I want to say Tommy.toString, right? Because that's part of it, and I want to print it out. So I want to say console log Tommy.toString. What do I get? This toString is part of my object super duper class, right? The one that becomes part of everything. I can't do it like this because toString is a method. I need to put in the same syntax that I would do is to call the method, right? So I'm calling the toString method that's built into the student class because of inheritance from the object superclass. So save, and then we'll do something like Control F5 to test it. And what do I get? Oh man, how come it's giving me this? Because I have to specify which project is the default project. I have more than one project. I want to right-click on my person project, right? And if you go down here, see this as startup project. You can set it as a startup project, right? So I set as startup project right here. So now my person project is my startup project, not my my lesson 5, right? So I can do something like Control F5, and then it'll bring up person project as student. That's what toString does. It didn't tell me anything. In fact, toString is absolutely useless for me right now. Why is it there? I mean, all it tells me is that Tommy is a student. That's all he is, right? So I'm just converting what he is to a student, right? But what I actually can do is override the toString class. The toString class is made to be overridden, right? So I can make it meaningful. Let's get back to our PowerPoint and talk about how to override, right? GetType is cool, returns the type or class of an object. So what's the type of my object, Tommy? The type is student, right? That's good. If I want to compare two types and say only students can do this method, only students can have this, then if GetType is student, if that's true, then do something to the student. If GetType is teacher, then do something with the teacher, right? That kind of stuff, right? Equals is when I take two objects and see if they're equivalent to each other. The only time that's going to be true if they're both of the same type, right? And getHashCode is a unique code for each object, right? That's identifying almost like a unique identifier for each object. Because when you create an object in C# or in any other language, by the way, the compiler assigns a unique identifier for each of the objects, right? Not as useful, but from a background perspective, it's good to understand what that number is, right? Every object has its own address, if you will. All right. So we can do that. We can say whatever the name is, what's the type? But I want to override, and this is what I want to do here. I want to override the toString method in my class, right? This is the first time we're overriding a method, right? And this is the format we're going to use: public override string toString. Okay, let's try this out. So I'm going to go back to my class, and this is for my student class, right? I can have a toString method that's built into my student class that tells me the stuff that I want, right? Actually, we did this already in another example, but we used display, right? So instead of using display, I can use toString, right? Because it's built in. So I mean, I can make a meaningful use of it. So here's how we're going to do this. Public override, right? And now look what it tells me. IntelliSense tells me which one you want to override, Tom. Do you want to override the equals, the get hash, or the toString? Those are the ones I can override. Let's override toString. When I do that, right, it gives me the structure of what I want. I need to return something. Obviously, it's not going to be this base toString. That doesn't make any sense. It's just a stub that Visual Studio gives you automatically, right? What I want to do here when I do my first override, this is the first override we're doing together. We're going to do lots of them from now on, right? But we're going to try and return some kind of string that has to do with the actual object itself, the student object. Student object has name, an age, and a student number, right? So if I want to do a toString, I want to do something like that. I want to create a string. So let's say, for example, string. We'll call this return string, right? The string that's returned, right? Is equal to a large string. So we'll say something like this: name, name first, which is some kind of value, right? Right. And then what we're going to do is we're going to say, is it \n or /n? Come on, guys. \n or /n for the new line? We'll try it again until you guys tell me the right way, right? Name, age, right? Which is going to be number 2 or number 1, right? And then also we're going to do a \n. I should do it right there like this, right? And until you guys tell me what the right way is. And then the next one is student number, which is 2. And then what I'm going to say is this is equal to this string, right? If I go to try and do this, I can't add these in, right? That's not how it works. I can't format a string like this, or can I? Well, maybe I can do something like this. String, I can use a string superclass dot format, right? And I can bring in the string and then the objects that I want to format into my class. Let me just open this up so you can see it more. That's something new you guys haven't seen before, right? Maybe. And my format for my string would be the name would be the first one. So this dot name, and then this dot age, and then this dot employee, or sorry, student number, right? And what I want to do is, just so you can see it better, I'm going to split this over 2 lines so you can see this better. Not because it'll work this way, but I could do this like this, right? Because it doesn't really matter. C# is looking for the semicolon to end the line, right? So this string, return string, is equal to all this, right? And so down here, when I return it in my toString function, I want to return something I call return string. Who is pinging the crap out of me? Someone is, and it's not required to be answered right now. All right, so return string. The thing I've mentioned is this. Now, could I, instead of declaring a string, could I put it down here? Absolutely. And that's what's typically done. Typically, we don't use this other value, right? And this return string makes no sense because it's just going to be temporary, right? So what we really want to do is one of these, cut, and put this here, and get rid of this. This is the more elegant way of doing it. We're using the string.format. String format is actually a new thing for C#, fairly new. And what it does is it allows me to create a string and format it the way I like before I assign it, right? Let's see if my \n's are correct, or is it /n, right? So now if I go back to my my program class and I go toString, Tommy is a student. If I go toString, it's gonna I've got an overridden method that I can use, So I'm going to say Control F5, and it says name, age, student number. Beautiful. That makes more sense for a toString method than using my standard method, my display or something like that. It's built in. Might as well make toString worth something, right? And by the way, we do that all the time. Whenever I create a class, I sit there and I say, what's my toString method going to do? All right? By the way, you can make this as pretty as you like. I made it really ugly here, but you can add additional features, like you can surround the name with different things here. Like if I really want to, I could do stuff like, well, you know what? I want to surround the name with stuff. You can format it the way you like. Like example would be like this. I want to kind of add these things in there. And then if I want to format the string, it doesn't really matter, right? Because I want to keep on, doing this thing. You got to be really careful here because it doesn't know when I split a string between two lines what I'm doing. So be careful about this. But one thing I like to do before I do this is do all my formatting like this. So I say, well, my age is going to be there. My student number, what is it going to look like? It's going to look kind of like this. Watch me here when I do this, right? Here's my student number. And my age is here. Sorry, I didn't do that right. My age and a new line, right? And here's my student number. Right, it's just reformatting here. My student number down there. How much room do I need for my stuff? As an example, I can add in additional padding. So for my string, I could add one of those in there. Right, so this is what my string is going to look like. Don't worry about what it says right now. It's just errors because it doesn't understand the string separation. But what I'm doing is I'm formatting what it's going to really look like later on. Right? Bear with me while I do this. Then I add another one of these. We can take away all the separation in a second. Let's say I want to make it like that, and I want to do a \n over here. I want to do a \n over here. And then let's say I want to do some kind of, I know that the student number is going to take too long. I don't want to put the right side because the right side will move around because the size of my student number is a certain width. By the way, I can change that. I can make it a certain minimal width for everything, but I won't do that right now. So I have kind of a format of what I want this thing to look like, and now I can kind of get back to what it's supposed to look like. So I can put it all back. It can work, right? Because this is what it's going to really look like in one line. There you go. So when you first see it, you might see something like this. And you're like, what? What is that? It's just me formatting, right? And then if I go back, if I save this thing and see how it really looks like, if I did it correctly, then again, I can go back to my person and Control F5, and I can see what I get, right? So it didn't quite work. So I forgot to put the \n behind. Almost. Let's try it one more time. One more thing. I forgot the \n behind the student number right here. And Control F5. There. So it looks a little nicer than before, right? Well, you can format it the way you like. I can always use, instead of string format, I can always use string concatenation as well. So I do one string plus another string. Every line is a new string plus another string plus another string, and then it makes my string the way I like, my whole multi-line string, and then I can make it, it'll print out like this too. Here's what I don't want to do. I don't want my return, my toString, to go to console write line. I don't want that. I want my toString to produce a string. That's what the output of this toString method is. Okay? I'm just using the string format method because string format gives me the ability to format the stuff that I'm interpolating, right? Like for example, if I want to give my student number a certain number of characters, is there some way that I could use a string format to do that? And then for me to search that up, I can go to string format C# function, string.format C#. I look at the C# code for string format, right? which I highly recommend you look at your APIs when you start using them, right? It gives me a couple of options. These are the overloaded constructors list. These are all the different kinds of constructors it can take. For example, I can also put in a format provider, right? If I really want to, right? Or a string and an object, like this is what I've done before. A string, object, object, string, object, object, object. So there's different things here. Let's look at this one for a second. Or a string object array, which is what I've done, right? So let's say if I go a string and an object, right? How do I do that? It tells me I've got my string format and on my object. What's my formatting? My argument, my format exception. It gives me these two exceptions. What's my formatter or my interpolation? How can I find what the format is of my string, right? So one is format is a string type and a composite format string. Let's see if that tells me what that is. So string format. And inside my curly braces, it tells me what to put in, right? But I can also do this, X, E, N. And those is the type that I want to use, right? I could also do alignment components for my formatting. Like, for example, I could say, this is the names and hours. And when I format it, notice that I have is the first value, right? The first value is represents the item or the object that I'm interpolating inside my string, and the second value is the spacing, right? So for example, notice that it says -20 here, -20, right? So -20 here for my console write line. That's my spacing that I can use for my format. Also, the format component tells you there's different things you can do. You can format it for datetime, integers, and so on in different types. There's all kinds of stuff, escaping braces. So you can have all kinds of different stuff in the format string to kind of understand what it means. So string formatting is really, really powerful. I'm not going to go over too much detail in this course because you guys should know it already from Programming 1. You guys did learn string formatting in Programming 1, yeah? Some people are saying no. Some people are saying yes. Depending on the professor you had, you should know how to format strings, right? But so you can put other stuff in there instead of what I've got in there, right? So please take a look if you forgot. Take a look at how to do string format. But the bare minimum is the hours or anything in the curly braces is just interpolating. Okay. All right. So that's what toString is. We've done the toString method, right, which we were capturing, which is right here. This toString method we've created. Now they're using this in this example here. They're actually using string concatenation, where they use the plus operator to concatenate the values within the string. That's also valid. As long as it returns a string, it doesn't really matter how you get the string. Okay. The equals method is when you compare two objects of the same type, and you can always override that as well if you really want to, right? So here's where an example of how we can override the equals operator for a particular class, right? And I can basically say, well, check to see if these two types are the same, because we're using the getType method. So check if this type and the object that we're passing into the equals is the same, and if it's true, return true. If it's false, return false. So you can compare the two objects. And you'd have to do that if you want to have some kind of if your equals method means something for your class. It may not. Your equals method may not mean anything for your class, so leave it alone. Right? Like for a person, do I want to compare two people? No, probably not. Same thing with students. If I want to make sure that two students are the same, it's not going to happen. Hash code, I'm not going to talk about. Again, it's a special code for that for the employee, and it gives you a special hash code that's again kind of dialed into that specific object that we're creating. Base class constructors, we've kind of done this already, right? But instead of calling the constructor that we have, like for example, I have an employee class and I have another class called a commissioned employee. And here what I'm doing is my commissioned employee is a derivation or a subclass of the employee superclass, right? Notice that : employee is here, which means that commissioned employee inherits from the employee class. Well, if we defined a constructor employee, the console write lines employee constructed, I want to call the base method. Here's my commission employee constructor, and I'm just saying commission employee constructed, right? This is just calling my own, right? What I can do is also call the constructor from the superclass. Now, why would you want to do such a thing? Because sometimes what happens is, right, what you want to do is you want to call something that already exists. Like here's an example of a commission employee, and I'm passing in values to the superclass, which is what I've done already. So I'm initializing the values in the superclass because the superclass's constructor, there's only one constructor, and it needs, you know, a number and some kind of string in this example, right? And if I don't give it a number and a string, I'm going to get an error because I'm inheriting from the superclass, and the only constructor I have, the only way I can construct an object based on the superclass is to use this constructor, right? And that's what I've done here in my person class. Notice how my student, I have to have a constructor for a student that sends the age and name information back to the person class. If I don't have that, my student class will not be complete because I don't have an empty constructor. If I created an empty constructor for my student class, an example of that would be, or sorry, for my person class. So if I said, you know, public person, and then open parentheses, close parentheses, and it was empty, then it would be acceptable. I don't have to send anything in because there is an empty constructor in my person class, the class that the student class is deriving from, right? But that's not the case here. There's only one constructor that I've declared in my person class, and it's one that takes age and name. Remember? So I go back to my Solution Explorer, and if I look at my person class, you can see that there's only one constructor that takes age and name. I don't have an empty constructor, so therefore I can't pass nothing to my base class. I can't do that, right? Even if I want to, it'll give me an error. Okay. Here's something that I want to introduce today, and we're going to come back and talk about tomorrow or the next time we meet. So I have a question for you guys and girls that are out there, right? Am I ever going to create an object of the person class? Ever? Chances are not. There is no person that doesn't have some kind of occupation or standing or status, right, that exists. So in fact, the person class will never be instantiated into an object. I'll never create an image of the person class into an object. I'll never do that, right? My person class then is like a blueprint, or what we like to call an abstract class. We create the person class as an abstract class, and we inherit it, but we can never instantiate it like a concrete class. So there's two types of classes: abstract classes and concrete classes. Concrete classes are classes like student class, which I'm going to use. Abstract classes are more of like design. They're my blueprint that my concrete class, the student class, is going to inherit. And they're only made to inherit from. All right, the idea of these abstract classes. Here's some stuff you have to know about this. So this is one from which you cannot create concrete objects. So I can never create an object. I can't go this class. So example is person Tom is equal to a new person. Can't do that. We'll never be able to use a new keyword with an abstract class. Doesn't work. It'll fail, right? I have to use the keyword abstract when I declare the abstract class. So it has to be something like this: public abstract, whatever the class name is, so person, right? And I can declare it. It usually contains, but does not always, abstract methods. And abstract methods, right, as an example, have no statements. What, Tom? What are you saying by that? What do you mean, have no statements, right? Abstract methods, and then the derived classes must override using the override keyword. Why would I do that? Okay, let's go back and talk about this a little bit. When we create abstract classes. This is a new concept. I'm introducing it today. We're going to handle it again because we're running out of time. I'm going to handle it again on Tuesday when I see you guys, right? So let's change the person class to a abstract class. So I'm going to say public abstract class. Now, does it change anything right now? Well, on the diagram, it's important to note, you can see that the person class has abstract class on it, right? This is one thing that changes. And you have two classes that are derived from it, right? One that's a student and one that's a teacher, right? In my program driver class, if I try and do something like this, I try and say something like person, new person is equal to a new person, right? I'm going to get an error now, especially even if I pass in the proper parameters. If I pass in age, which is like 25, and name, which is like Tom, still going to get an error. Why? Because even though I've satisfied the requirements of the person constructor, right? If I kind of kind of put my mouse over, it says cannot create an instance of the file of the abstract class or interface person. So I can never instantiate an object anymore once I mark it as abstract. Why would I want to do that? Business rules again. It goes back to thinking in real life. Example of this, of an abstract concept that I'm never going to have. I don't really have something called an animal, right? Let's go back even further than the person. Mammal, all right? A person is considered a mammal. Why? Because it has hair. All people pretty much have hair somewhere on their bodies unless you get something done, right? I'm just saying, have hair, and they're warm-blooded. Those are the two things that are common to all mammals, right? But can I go something like this? Mammal is equal to whatever one I want to call it, new mammal. Okay, what shape does that mammal have? Does it have 2 legs? Does it have 4 legs? Does it have 3 legs? Does it have any legs? Right? There's not enough information, right? So therefore, because there's not enough information to define the shape of a mammal, it has no shape, and therefore it's abstract in our mind. The concept of a name is abstract. We cannot create something concrete that's a mammal. Let's go further down. Further up, I said, a mammal is an animal, right? Animal has no meaning whatsoever, really, at the end of the day. Animals can mean lots of different things, right? We need to get more specific. Just like person means nothing. Person could be a male, female, it could be old, young, it could be many, many things. Like, I can't picture just a random generic person. There is no generic person that I can like clone. You know what I'm saying? I put the person inside a pod, I press a button, all of a sudden, ping! I don't know what that person's going to look like. It has to have a shape, right? But when I start going down the line, and I'm sorry, it's a really weird analogy, but if I start being more specific for the person, like for example, even student in some ways is still an abstract concept. International student gives me more detail, right? International student that comes from India, as an example, gives me even more detail. Now I have a shape in my mind of what an international student from India looks like, right? And I can keep going down. What part of India does that person come from? Okay, fine. What family does that person come from? What sector? Okay, fine. Now what is it, male or female? I can keep going down the line until I get an actual shape. We can't do that forever, because then we're going to have inheritance, like a big domino effect of inheritance all the way down. So for business rules, we got to look at see what the most business rules are going to be. I'm going to give you an assignment next week called Abstract Planets. It's a new assignment coming out, right? Abstract planets. If I tell you planet, right, I want you to think of this as in general. If I say planet, planet means nothing to you. Planet means, I understand it's a planet, but there's different kinds of planets, right? There's a rocky type planet like Earth, and there's a gas giant kind of planet like Saturn or Jupiter, right? Or Neptune. Those are gas giant types or gas-like planets, right? So that's what's coming next week. You're gonna get a new assignment called Abstract Planets, and we're gonna create an abstract class called Planet, and we're gonna inherit from that abstract class and create 2 types of planets. And from those planets, we're gonna create actual other real planets, as an example, in our solar system, right? So the idea of abstract classes, I want you to take it away. I'm going to test you on it next week. Remember, next week on Friday, we have a little quiz. Next week, Friday, by the way, or whatever. And next week is the last week before our test, midterm test, because next week is week 6. Our midterm test is going to happen week 7 on the Friday, right? That's when it's going to happen. We're going to do a little in-class test on that day. And chances are I'm going to get you to build something in that hour-and-a-half space that we have, okay? So you need to know your stuff. Please don't let other people do your work for you. I know some people do that. They kind of work with somebody else because they don't get it. Do your assignments as much as possible on your own. So when it comes to exam time, test time, right, you're fast enough to be able to finish. Even though you understand stuff, doesn't mean you'll be able to be fast enough in an exam or a test to finish off. Yeah. Yes, it'll be open book. We'll do a little quiz next week, right, on this stuff, and the following week is the actual exam, okay, or a test, which is worth more marks. Guys, have a great weekend. We'll talk about abstract classes and interfaces next week.
I have a quick question. So like when you're making